welcome.
Hey, thank you.
It's a little bit of a crazy night because we are packing 4 people in, which I've never done before. And so we were having to get AV stuff working on 4 laptops all at once. But thanks for your patience, I appreciate it. Welcome, this is the Seattle Postgres User Group. Great to see everybody out here tonight. My name is Jeremy, this is Lloyd. Lloyd's been here running the Seattle Postgres User Group for those of you who haven't been here before since like what, 2010 or something? I don't know, long time. So we've had this group going for a very long time. Let's see. What we typically do, I'm going to run through a couple quick announcements. I'm completely unprepared tonight compared to my usual, like having notes and stuff. Bathrooms are out the back if anybody needs to know where those are. Out the back door to the right, I think. Let's see. My other big announcement that's top of mind for me right now is that in November, there is a big conference, tech conference, that happens here in Seattle every year called the Past Data Summit. And for the last couple of years, this user group, we have kind of gone and set up a Postgres community booth at this conference, and it's a really cool thing. The conference organizers kind of reached out to us and they said, hey, we'd love if there could just be a booth for the community on the exhibition hall floor. If you think you could find some people that are enthusiastic about Postgres from Seattle, just to kind of come hang out at the booth, answer questions about Postgres, about the open source community, about the software. So that's a cool opportunity that we've had for the last couple of years. I'm way behind this year. Normally, I'm like looking for volunteers 2 months ago. It's PASS is going to be coming up, I believe it's the 2nd week of November, if I remember right. So if anybody here is interested it helps if you've spent a little bit of time kicking the tires on Postgres, but you don't need to be like an expert at all. Like you don't need to be a wizard that knows everything about Postgres. It's a great opportunity to come talk to people. People have all kinds of questions. They're curious. So yeah, if anybody here is interested, come chat after the meetup, and I'll kind of get your info. We can get in touch.
So it's Past Data Community Summit, November 17th through the 21st.
November 17 to 21.
And that's here in Seattle?
Yes, it's at the convention center downtown. It's a pretty big conference. It's a lot of fun.
What was the first word in the title?
PASS, P-A-S-S, Data Community Summit.
Rick, you've been going to this for years, haven't you? What's just a little bit of background for folks on the Past Data Summit conference?
Well, don't hold it against them, but way back in the day, it was a SQL Server conference. Because when you went to the tech conferences from Microsoft, there's usually like one track in SQL Server. So it's hard finding enough content, so they started doing a Past Data Community Summit to just really drill database stuff. But yeah, the last few years it's been much more open, trying to integrate a lot of Postgres content also.
Yeah.
Yeah, it's always a really good event.
I mean, it's been running since 25 years maybe. This conference has been going. It's not a new conference.
It's the 25th year.
Yeah, it's not a new conference. It's been around for a long time, so fun place. I've enjoyed it. I've gone the last 2 years, so it's fun. So what other announcements? There's probably other announcements that I'm not thinking of.
Most people here aren't going to go to it, but PG Down Under is, I think, on the 17th, Friday the 17th of this month. I will be there.
Yeah, the New York conference is going on right now or just finished up or something like that. I've seen a couple call for papers open up at other conferences. A couple of you guys have given talks here. I'll just put one more quick plug in. I have a goal every season as I'm trying to figure out who can kind of come and do a talk here. One of my goals is that every single season we're getting somebody to come here and do a talk who's never talked about Postgres before, hasn't really done talks before. I think one of the reasons to have a local kind of user group like this, where it's not going to a big conference with 20,000 people or something, is it's a great place to just kind of share a couple things you're working on, where it's low pressure, it's not a big deal. You don't need to have this big polished presentation. So I am right now starting to work on the schedule for the spring, which we skip January, we'll go from February to February, March, April, May, June is what we're going to do. So there'll be 5 meetups in the spring. I would really love anybody here, again, something you can talk about, just something you're working on, something kind of tangentially related to Postgres is the idea. It's the Postgres user group, that's our theme. But I'd really love some topics for the spring.
And it's a nice way to work your way up, because what I did is I started the user group here and gave presentations at the beginning. And so I started at the user group level, then I went up to the local conference level, things like Linux Fest Northwest, doing Postgres talks, and then went up to more of a regional conference, and then to national, and now do international conferences. So starting at the user group level, giving presentations is a way to work your way up into doing large-scale conferences and being a presenter.
Yep.
Because I don't like speaking in front of crowds, so it's a lot easier to speak in front of a much smaller user group to begin with.
I just remembered the other announcements I usually say. For anybody who's new and hasn't heard me say these 100 times, I think everybody got name tags, which is awesome. I do ask sign in, please, because that's basically how I know how many people came and how much pizza to order. There's no contact information on the sign-in sheet. If you want to know about meetups, you have to go to meetup.com and sign up there. That's where all of the communication about future meetups goes. So if that's not how you found out about this, make sure you go sign up for that and watch for emails. And then the last thing that I always mention is that, which is our little user group lending library, which is just a big pile of books and a clipboard. You are welcome to borrow books. It's not really a big deal. The only thing I always say is if you borrow a book, I would like some actual real contact information on the clipboard, if you don't mind, so that if it doesn't come back in a year or something, I can just kind of reach out and ask how good it is. So that's the library. Yeah, feel free to browse, borrow something if you want to. Yeah, we've got some fun stuff in there. I think that's it for announcements, unless you have anything else.
I'm good. We do have our dates set for next year. So if you've got the ideas for things to speak about, it will help us set the content for next year.
Yes. All right. So I'm going to introduce. All right. Tonight's gonna be a little crazy because, like I said, we got 4 speakers. We're kind of doing a lightning talk-ish kind of thing. So everybody's gonna kind of do this quick thing. And you told me 3 times, and I'm still afraid I'm going to pronounce your name wrong because every time I look at it, my brain wants to say it differently. So the pronunciation. German. Okay. Doing my best. German, I'm going to just read the bio, is a principal software engineering manager with Microsoft on the Azure DocumentDB team. You were an Apache Cassandra catalyst, you told me, which sounds exciting. And it sounds like you have some stories about Cassandra. I'd love to hear more about that sometime. Also was an architect on Rackspace's Kubernetes team and led HP's Cloud Advanced Networking team and a core reviewer and contributor to many OpenStack projects. So please give a warm welcome. I think we're really privileged to have Armand here tonight. And then also you mentioned a lot of talks at major conferences and teaching computer topics at UC San Diego Extension. So a lot of really cool stuff. And here tonight to talk about DocumentDB. So welcome and thank you for coming.
Yeah, thank you, Jeremy, for introducing and giving me the opportunity to talk tonight. As you said, my name is German Eichberger. I'm a principal software engineering manager at the Azure DocumentDB team. Oh, I need to talk here.
Microphone here, it'll make it a little easier.
This one's better than my.
This one doesn't go up there. That's just recording for the recording piece.
Okay.
We do also have a handheld.
Oh no, then I will just stay here. No problems. I can do that. Okay, so I'm at the Azure DocumentDB team, and today I want to talk about DocumentDB. I don't know if you guys heard about it. How do I get to the next? Should have thought about that. Okay, so quick about me. He introduced me. I work on the Azure database group. We have a whole building on the Microsoft campus. So many databases. As I said, he said Cassandra. Now I'm doing DocumentDB, which has also to do with Postgres, OpenStack, Kubernetes, and the big thing. I talked to a bunch of people already. I'm from San Diego, and a lot of people are saying they're happy that they are not in San Diego. So. They didn't expect that, but we take the crowd as it is. But let me talk about what is DocumentDB. And since the lightning talk, I only have a few slides. And that's our website is DocumentDB.io, because all the other com already was taken, I guess. And so what we are is an open source MongoDB, or Mongo API compatible Postgres extension. and we also have a gateway to translate the Mongo protocol to Postgres. Who knows what MongoDB is? See two hands, not, so let's tell them. So basically it's a schema-less database, and you are storing JSON.
2 people in here know what MongoDB is?
No, 2 people don't know what Mongo.
Don't
Don't know. No, I was asking who knows, and I counted the ones without the hand. So 2 people didn't know, and MongoDB is a schema-less database, so Postgres schema full, is this even a word? So, and basically you are storing JSON documents, and then you have to basically query over the JSON documents and find the fields and stuff. So this DocumentDB grew out of a project from Microsoft. We open sourced it at the beginning of the year, I think, and then we donated it to the Linux Foundation just last month. And so now it's not anymore Microsoft, it's the Linux Foundation's one, so it's more open source than open source, I guess. And the contributors, first it starts with the 2 biggest companies in Seattle. So it's us, Microsoft and Amazon. And then it's always something important if we agree on something, which is rare. So they say that. And we also have other companies contributing, Rippling, Yugabyte, and AB InBev. So we also have the beer company. And then, so now as you know roughly what it is, why are we doing that? And the reason is, at one point in MongoDB's history, they decided that they didn't want to be as open source anymore, and they released their thing under the server-side license, which is very restrictive and makes it very difficult to contribute to it and also to run it for free. And so ours is completely open source, and the thing is. So I don't know if you guys remember, anybody knows that IBM actually invented SQL, the structured query language, back in the 60s. And if you want to run SQL, back then you had to buy a mainframe. Otherwise, you couldn't run SQL, so you had to go buy a mainframe. Not everybody wanted to buy a mainframe, but they still wanted to run SQL. And so over the years, SQL became an ANSI standard, then it became an ISO standard. And then with every time it became more and more standard, more and more companies joined, there were more and more databases. And you probably know that Postgres runs on SQL. So if that wouldn't have happened, probably would still have Postgres, but it wouldn't have SQL. And so we feel that that's a really good thing to take something like SQL to be a standard. Now, the same we feel is needed for this Mongo API. Right now it's proprietary. If you want on Mongo, you have to go to MongoDB. They basically call all the shots. And what we want to do is we want to do the same thing which has been done to SQL. We want to do it to Mongo. We want to make it a standard. We want to agree, have a standard committee, and basically make it so that there's a flourishing ecosystem of multiple database vendors running this Mongo API. So that's our goal with that. Very noble, as you know. So yeah. And then the last slide I have, and then I will give a live demo. So what are we actually building here? Well, we have the Postgres extension. So Mongo's using a database format called Pierson. So we added this data type to Postgres and all those things. We have the gateway, which is written in Rust. We have a VS Code extension because that's where we work. So yeah. And we are working on a Kubernetes operator, which is on top of the cloud-native Postgres operator. So it's already out there, open source. We have big plans for the operator. That will be also exciting. So let's see. So let's see if we can.
If you want to move around, you can use this one.
Okay, I will. Okay, so let's go. Gosh, let's see here. Hide. Google is. What did I do? Yeah, this is okay. So if you want to try that at home, so we have we made for everyone a Docker container you can run, and so here I'm running that in the background. The port that will be where Mongo's listening. So they gave me the thing to move around. Here, let's move around so I can show it quick. So this is the port, where we're listening. This is where we keep the container. And then I have to say, because it has to be secure, there has been security things. When we use default passwords, people will know them and break in your laptop, I guess. I don't know. So we require you to give us a username and a password. So there will be username and password. So then quickly run that. So now it's running. We have this magic number, which is the, probably put it back here. It's container number. Then I have to go to the third thing. So here we are running, did I copy it right? Yeah. So here we're running a Postgres inside it, so as the Postgres user. And now I have to look at my cheat sheet, which commands I want to run. Because I felt you guys are the Postgres user group, so I should do it all the Postgres way. So basically here we added, that's our extension, and in Mongo they don't call they call tables collections, and schemas they call databases, and so that's so we want to create in the DocumentDB database, which is ultimately created but exists, the collection fruit, as I said, table analog, and then we want to insert a document, and then we have to say the database, the collection, the guy schema, table, and then the ID, and here's the JSON document we are inserting there. So let's do that, and it all happened. And then most people interact with MongoDB for something they call the Mongo shell. So this is how you get into that. And then you have to say use document. Probably should go back. No, I have to type. Okay, should have thought it through. DocumentDB. And then back to the cheat sheet. So then we can do that stuff. So the command, once you're in the database, then basically you're going to find all the things in this fruit collection. And you see here, that's exactly the thing we inserted on the Postgres side, you can now find on the Mongo side. And I also said the other thing we are working on is, do I have it? A laptop. Is a VS Code extension. Let's see. VS Code. Let me just type. Gosh, what did I do? Yeah, crashed. So we have a VS Code extension right down there. And here's DocumentDB local. That's how we call the local thing. Already created the connection. There's a DocumentDB database, our fruit thing. And then when I double click here, have the fruit again. So works everywhere. And I promised we also have a Kubernetes thing. So I don't know who knows Kubernetes. Probably. Yeah, the people who didn't do the Mongo thing, I assume they're lying. So I'm not explaining Kubernetes. So this is Headlamp, which I use, which shows the stuff. So we created a custom resource, which should be, where did we, DocumentDB? Did I do? There, DocumentDB, so we have a custom resource, DocumentDB. I have one running. So this is something which is under development on our side. But yeah, you can use that too. So it should work. And basically, this is our CRD. So you can say, well, I wanna have one instance per node, one node, and then can say the PVC size. That's your database size, and then you get a DocumentDB running, and then we also give you here the connection string. Then you can paste that into Mongo shell. If you want to do the Postgres thing, we haven't made that as easy on the Kubernetes side because we assume people want to use that. They're more interested on the Mongo side, but yeah. So hopefully I didn't time. So I should have time for questions. He gave me 20 minutes, so I have like at least 5 minutes for questions. Anybody has questions? It was a quick
thing. Is the document that's stored in Postgres opaque from the Postgres perspective, or can you do things like add Postgres indexes for particular fields?
Okay, so we have our own.
Why don't you repeat the question?
So the question was about, so when you insert a document, how does this interplay with the Postgres indexes? So the way that is, we made our own index. So we ship with that something called a RAM index. So there are different indexing systems, B-tree, RAM, and what Gin and RAM, all named after strings. So we made our own RAM index, which is going to index, so that it can index the fields in the document and then find it faster. And there's an index, there's a operations push down and all that stuff. This is something we actively are working on. There's a thing about maybe going back to B-tree, so this is something which is we're definitely actively working on, but yeah, the standard Postgres indices won't work because it's a JSON, it's a Python document, so we made our own index. And we also wanted to support the Mongo operations, which sometimes differ from Postgres.
I want to follow up on that.
Yeah.
So when you say the indexes won't work because it's BSON, are you? I think I understand what you're saying, but I want to just clarify. Is that because you guys created a custom data type?
Yes, we
Is
did
that-
custom data type
Okay.
Python. Yeah.
So it's specifically because it's the custom data type. Then when you do, I think when you do custom data types in Postgres, you have to implement like any kind of indexing support into that data
Exactly.
type.
So we did implement the indexing support, and then we also wanted
Yeah.
to have the Mongo operations all on the index. So we implemented operations on index.
Yeah. So part of the question was like, I think if I understood your question right, was like, can you just interact with this from like Postgres, like log in with PSQL? I think the answer is yes.
Yes.
There's nothing that stops you from interacting with it. It's just that to your indexing question, because of the fact that it's a custom data type, which Postgres, you could add your own custom data types too. You'd have the same constraints.
Yeah. So yeah, as you've seen, you can totally go in with PSQL, and we have, and everything is very named very much like a Mongo command. And that's how we interact too, just more programmatically. And there's more. We also have some more sugared syntax when you go to our. We have a Discord channel, you have to ask questions. Our docs are still not ideal, but also have more sugar in the syntax so you can interact with it and kind of do joins between document tables and normal tables and stuff like that. So all works. It's just something we don't focus on as much since we want to have people do Mongo compatible stuff.
Yeah.
Yeah, more questions?
So this is basically a way to replace MongoDB by using Postgres.
Yes.
What is the performance difference?
So the question was to replace MongoDB with Postgres, and then I say yes, and the performance difference. So the performance difference is that's a complex question because it depends really what you are measuring, what workloads you are doing. So for instance, we in some benchmarks our writes and reads, point writes and reads are faster than Mongo's, but then our queries are not. So it's something we're also working on to improve performance. But in our tests we can definitely Postgres is a faster engine for at least doc writing and reading than the Mongo engine they use. But then when it comes to more complex operations, they have a little bit of a lead. Then the next thing is they can do distributed queries, which is which we are working on, but that's something we don't really, you don't get with the open source version. So I'll say that. So if you compare that, where you can distribute, then it gets more things. Yeah, it's something you need to test yourself. There's lots of nuances, but raw performance, read-write, we are better.
So, or comparable at least.
Yeah, we are comparable. If you just use read-write, you are good. Then if you have more complex workloads, you have to measure and see.
Are there any other difference between DocumentDB and MongoDB, like non-functional difference?
So that goes back to the question is, are there any functional differences with MongoDB and DocumentDB? So that goes back to the thing that I talked about, that it's not like SQL where there's an ISO standard. So tomorrow MongoDB could come out and say, hey, we have this new function. And then it would take us, of course, time to implement that. And so we do all the time compatibility tests, and we have, I don't know, is it like 80? So we have all the importance of like So depending on the day and whatever, so I think we are at 80, but I would have to check. So but we are increasing that. So there are the two things. So right now it's 80. We want to have it to be a standard, and it's a standard. Then we can, go to 100. So this is. But yeah. So everything important is supported, and if you compare it to what Amazon, they have something confusingly also named DocumentDB.
Yes.
If you compare to them, this thing is more compatible than Amazon's. That's why they chose it. Yeah, more questions?
One last question.
Oh, only one more question. Yes.
So why would I use this over Mongo? I mean, you're talking to the Postgres group, so you love Postgres, but
Yeah. So so the question is, why would I use this over Mongo? So there's one thing is you might not agree with them that their SSPL license is the right way. So that's one thing. And the other thing is you might be more familiar with Postgres and then saying, well, I don't really want, I know how to run a Postgres server, but I don't really want to deal with Mongo servers. And the other thing is you might not want to pay, I don't know, I think they give you a free community edition, but I don't know how much commercial stuff you can do with that. So there's also a money kind of thing, especially if you want to run it as a service, like some companies do. That makes a big difference.
Like some companies, like which ones? I would add on to that, just kind of speaking from a different perspective, just something that often comes, I'm at a large company where we have lots of databases, probably, just tons of different databases are all in the company, but when somebody comes in and they're they want yet another database, and then they want some team to manage it and some team to run it, so you do a trade-off. You kind of have to do a value proposition. Sometimes it's worth it, but somebody at my company wants to now have Mongo. Now Mongo, it can be managed, but you still need, even with managed services, you still have to learn the syntax. You're still gonna have to kind of learn how to tune. You're gonna have to learn little bits and pieces, right? So it's, there's arguments both ways, but I think sometimes there's a lot of things you can do on Postgres. I mean, the other big one is vector databases, right? I mean, there are lots of purpose-built vector databases, but there are lots of people who want to just use Postgres for their vector database, and the driving reason might not have been a performance comparison. It might just been the fact they already had a Postgres team and a Postgres platform, and it was basically free. It's just add an extension, and now I don't have to have a whole new, I don't have to staff it with a whole new team to learn that new database. That can be an advantage sometimes too.
Okay.
All right. Thank you again for coming. All right, we're going to dive into some Python talks in a moment, but if you're able to stick around, I don't know if you have to leave early, then you guys are welcome to jump up with more questions and more discussion at the end too.
Who's next?
Andrew, were you able to figure something out for your PDFs?
You can use it on my laptop.
Why don't you go next? All right, we're going to do a quick shuffle. Thank you. Oh, hang on. Try to keep my thumb on it?
Yeah.
All right, and then Andrew, he's going to hand you a microphone to put onto your... we're trying to make you juggle everything at once. You're fine. Call you out, but you're talking at the top.
This one's
Andrew, you can walk around one. Stand by. We have
a clip on it also. So this is for recording. This one is for the
all right.
So you can either use this one, so I have the handheld.
We're going to try to make these jumps as fast as we can in the first iteration.
Yeah, well,
This one is for device.
yeah, I know. I don't have the bring up my mail for a second before I can.
All right. Great. I see you, Harry. Sharing the screen. Great, I see it. We're in business. All right.
Just hit the right key to.
Yeah. Okay.
All right. We're gonna try to jam 3 Python lightning talks in here. So I'm not gonna actually. If you guys don't mind, I'm gonna kind of skip intros and let you just kind of dive in again. We got Andrew first. We have Eric second, and then we'll do Harry third. If that works for you guys.
Okay. I come from a non-traditional Python background. I was told constantly I was stupid. Math was not for me. So I joined the family business, which was engineering and then finance. And I got bored selling, and because I was really good at it, but I had to do, they say you do 100 cold calls, you make 30 contacts, 10 of those people are going to become a customer. And I was like, that's way too much work for way too little result. And when I was a kid, my dad always said, I'll answer your first question, but after that, you have to figure it out yourself and then come back and tell me how you figured it out. So when the encyclopedia salesman came to my father's house, he bought every version of it and the children's version, and we had to read them as kids on a regular basis. The problem is the Python core library, if you've ever been told RTM or read the manual, if somebody doesn't like you and they give you a response, they'll say RTM, which means stop talking to me, go read the manual. This is what you need to do. I continued to ignore that, and I got RTFM a lot, which is read the effing manual. And then beyond that, you start with basically every mistake you can make, I've made, and then made them multiple times, and realized that I was causing a lot of my own problems in code. So I would have this Excel spreadsheet that was, we finally stopped working with it once it got to be about 300 to 400 gigabytes. Years ago, Excel did not have an upper limit on the amount of size that it would have. Now they do. They say it's a 32-bit, 2 gigabytes of virtual, 700 megabytes. But if you have 16 gig of RAM on your laptop, my laptop said it was only supposed to support 8 gig. Well, I put 16 in and it supported it. Great. Push the boundaries on everything that you have with technology. I think that's our job, is to break it, find ways to make stuff work, and I think we're kind of like data wizards. So we do a lot of stuff that other people go, that's crazy. But when you're first starting out and you're an FNG, you don't know what you don't know. So this is what typical people find. Well, how do you know what to do with this? So I realized quickly that my learning style needed to be figured out. I had to learn how to learn and learn quickly, or I was just going to spend a whole bunch of time spinning my wheels and getting nothing done. And to me, that's one of the worst things you can do, is get nothing done. It like drives me crazy. So there's visual. You see something, you kind of like imprint it in your brain, and then if I go do it, it sticks. And it's kind of like an eidetic memory, but I still forget stuff on a regular basis. Can you grab my notebook, the one with the green duct tape on it? I have been a fan of basic, cheap notebooks that you can possibly find. These are on Amazon, 12 for $12, so I would buy them in a case, and I use these to this day, for all kinds of notebooks, and there is never once one of the batteries in these has died. I still have notebooks from 2014 when I was trying to learn MySQL. I had on an entire page how to start up a MySQL server in Linux written out by hand. And it never failed me. Whenever somebody's like, oh, we can't do it with the internet, I was like, I've got the notebook. So having paper notes, one of the best things you can do. Auditories, you hear it and it sticks. I hear it and I've got 1,000 questions because like you mumbled your words. Kinesthetic, you need to do it to learn it and grab it and hold it and touch it. Gustatory, I had to pull this up off the dictionary because this is definitely not me. Using a sense of taste, touch, sense, like your whole sensories, you've got to like eat the book and hear it. And but some weird stuff does happen when you start listening to audiobooks in your sleep. They'll show up in your dreams and you'll be talking to that person. So I tried that. That didn't work for me. Joel Spolsky, Stack Overflow CEO, somebody recommended Joel. Well, it was Joel Gruss, not Joel Spolsky. I didn't know that. So me being stupid, I assumed this was the Joel they thought. So I started going to Stack Overflow. And that's a story for later in it. So you have RTM plus RTFM to, here, let me Google that for you. Mentors started to ignore me because I wasn't following what they told me, because I know what to do. I manage millions of dollars of money. I have all these hundreds of clients. I know what to do. Well, I didn't. So there's an old Yiddish saying that I just absolutely love. Wherever there is too much, something is missing. So the theory of constraints, Eli Golding talks about, if you ever want to solve a problem, look at the constraints. Musk does this with, okay, we have so much physical size of the battery, we have so much charge of each battery, and you kind of start digging the English channel from the French side and from the English side. You don't get it perfect the way you go through it. It's very iterative. I did not have a good laptop. I had an old piece of junk, ThinkPad, Excel, and ambitiously lazy. I was like, I need to figure out a way to do this. So I went from 9.13% call to close ratio to like 84% of my calls became a client who also referred clients. And the company was like, how are you getting so many customers and they're not leaving? Why? What's wrong with this situation? I was like, what's wrong is you're asking me what's wrong with this. I've told everybody what I do. Nobody listens because it's too basic. First one I would recommend is to write notes down, listen with a pen. I was told years ago, choose your words very carefully and then write down what the person said, come back to them a week later after you tried it and read to them the notes and say, this is what you told me, this is what I did, this is what I learned, what's next? I have never once had somebody say, I'm not gonna help you. They always go, oh my gosh, you took great notes. It shows respect for yourself. It also shows respect for them. So now I have a ton of people either on speed dial or I at a meetup or an event where I can go to and they're $300-400 an hour and I can get hours of their time. I don't have to pay them because I've tried to be a nice person and do them favors. But when you crash Excel on a regular basis, Microsoft was like, there's nothing we can do for you. So I kind of declared I will never touch Microsoft again for as long as I live because I lost terabytes of data. And they're like, sorry, there's nothing we can do. So I moved everything over to Mac and I've had maybe one crash in 11 years. I just don't have problems. Now when I started to go into multiple things, you will have problems. So I chose to accept that no matter what I do the first time or the first couple of times I do it, it's gonna suck, I'm gonna hate it, it's gonna be stressful, it's gonna be all the negative emotions. I can withstand that, but I'm gonna figure it out over time. And so now I expect things to fail. And when you expect something to fail and it fails, you're happy. You're like, hey, this failed, I was right. It's gonna be harder than I thought. I didn't prepare enough. But if you expect it to go easy and it's hard, now you've kind of nailed yourself to the floor. So expect it to be more difficult so you're more prepared. Document. Who here has ever been told document, 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 and we still kind of ignore them? Because it's stupid, it's hard, it's difficult. So being the lazy person, I wrote a number of scripts that automate the documentation of my code with Sphinx. So it's a Python script that you can download it, and basically it takes all of my functions, says these are the inputs to those functions, these are the classes, this is what can go into that class. And I don't have to write documentation anymore because I hate doing it. My code writes it for me, and I write tests. But you will have problems. Embrace it, write down what you did, take that to your mentors, and when you ask them a question, stop talking, listen to them, write down exactly what they said, and then show them your notes. I asked you a question, this is what you said, did I get that correct? I have gone back to this so many times that people are like, how do you keep such good notes? Just because I'm stupid and I know I'm not gonna remember it. So I have the notebooks. I have notebooks that go back a decade. And oddly enough, the stuff still works. So go to Stack Overflow, they said, because after I went to Joel Spolsky's, I got a 2-year ban for asking too many stupid questions. So then I had to go to the Puget Sound Python users group and ask them questions every week, bring my laptop to them. I screwed up. I don't know what I did. Will you please show me what I did wrong? They go, oh, okay. And they would fix it and go, okay, so what did I do wrong? What should I have done? How should I be thinking about this differently? data engineers, data architects, crazy smart people. I didn't come up with this, but I think it's like Hemingway, who, what, where, how, why, and when. Write that into the inside of your eyelids. It is one of the best ways to solve a problem. Simon Sinek start with why. Because if you have an emotional reason to get through something, you can plow the roads and leave a good trail for your team behind you. Going through all of this, I've gotten 5 promotions in 8 years. Not because I'm amazing, but because I can work with people and I know how to have people like me. And that was the opposite problem I used to have. People didn't like me, but I was technically skilled. Now they like me and I'm average skilled, but I know how to build consensus. I know how to empower people and talk with them. And also when things go wrong, how to solve problems. Puget Sound Python users group, there's about 11,000 of us. We have a private Slack channel. I call them the Jedi Council of coding and Python and SQL and pretty much every programming language you can think of. Some of the top people in all of Seattle go to this, and it's just a casual group. I learned so much from going through that. So my biggest thing is never be too cool for school, because as soon as you are, your career is not going to go any better, especially with large language models. Can do more properly prompted. They can do more in a couple of days than you used to be able to do in a week or a month. I mean, we can crank out code, but if your code is garbage, and if your questions are garbage, and if your details are garbage, garbage in, garbage out. I crashed a 19-year-old database because they had no tests, none. So now I write tests for all of my database. I broke a 600 gigabyte of my own code because I didn't have a plan. I disabled access to an AWS account, ran up a $15,000 bill. I literally cooked the GPUs on 2 iMacs because I didn't have well-run optimized code. I've pretty much done just all kinds of problems, but don't be an asshole. When you want to ask questions, write it down, because then you never, ever forget it. Getting started. So this is what Joel Spolsky uses. So he's the CEO or ex-CEO of Stack Overflow, which the site that I got banned from. Again, I was like, oh, maybe I should check it out. Can you use source control? GitHub? Do you use make a build in one step? Each one of these is like, it's not optional anymore. I don't think, and feel free to copy this. If you go to the Joel test, if you Google Joel test, this will come up. The multiple startups that I'm the advisor on, this isn't optional. And one of these things is, do you have fixed bugs? Do you have an up-to-date schedule? Do programmers have quiet working conditions? Do you have the best tools? This is where we have to advocate for ourselves to our managers. We need better tools. We need a quiet environment. When my headphones are on, go away. Don't talk to me. I need to focus. You want me to focus? You want me to get the code done? Thing. When I started out, it was doing consulting and finding companies. And so I just wrote this really simple menu. And I said, these are the factors, these are the things. And so this is all the stuff that both my degree and then the puppy group taught me. And it was every time there was a problem, it was how do I fix it? Now, I've gone from having no experience, no architecture, to I now have a semi-automated 24-step. This is mandatory on every project. My code flies. I've been able to speed up the processing time of code now using heavy GPUs 41 times. So something took 30 days, it now takes like 8 hours. So you can immediately compress time, but it's only certain kinds of data that works really, really well with GPU code. So every one of these is probably a page or 2 inside my code base that each of my team goes through, and it's not optional that they can go through this. And then they go, wow, our code is working really well. It's passing all of these tests. And every one of these is something that I got from somebody else, and then been compressing it down to about 24 things. When you work with an 8 terabyte database, or an 8 terabyte, so in the middle here is the size of the files, 8 terabytes, 2.5, multiples, 4, 2, 5, that much data, it becomes impossible to keep in your head. So now I don't need to. I use my systems. Now, the second half, and this is going to be a lightning round, not everything needs to be a database. Some things are best as like a Parquet file. This is a massive file so I used what I knew beforehand, which was finance. So I learned how to do algorithmic trading and then started studying how to write code that I could use to trade in the market, stocks, bonds, whatever. And it was really less about making money, because now I make way more money than I did ever doing this. I can handle terabytes of files. I have a 8 terabyte database right now that I don't really think should be a database. It should be a massive series of Parquet files. Only pick a database. I mean, I'm talking to you guys are the ones that know way more about databases, but do you have multiple concurrent writers and users? Random access queries for low latency, multiple tenant, otherwise use Parquet, DuckDB. But once you exceed 1 million rows or 2 million rows, probably go towards a database. If you have no standards, then that's going to be a problem. So find some standards. I copied Python, the Zen of Python, the explicit is better than implicit, all of those. I just accepted that I'm not going to want to think of those. I want to have that as my standard. And some tools are great, others are not. So I started writing my own tools. I had a hospital that contacted me and said, hey, we can't find an open source healthcare analytics. So I wrote one. And now I help them every now and then kind of work on it. Find something that you really, really enjoy doing and just build it. So now if I work on, most of my databases are in SQLite, and then I have a couple of friends that help me build Postgres databases, and I'm still not very good at it because there's so much involved. But Python is a great tool because now I can chew through terabytes of Excel and flat files and Parquet and all these things, and I can just use SQLite, and then when I need to get really serious, dump it into Postgres. It is a great tool, and I have a project right now, a startup that we're working with is Mad Kitchen. We need a massive database, and so it's exceeding 2.5 terabytes right now for training data, and most of that is what I learned. There's a book repository, free books over there that I borrowed a notebook from, and I just started doing everything chapter by chapter by chapter, and eventually it just starts to stick. Have some kind of standards that you write down, and those are your standards, whatever they are, and then enforce your standards, and you will have much better running code. And then when somebody who's much more senior looks at your code, they go, oh, hey, somebody cooked here. Somebody wrote good code. And years later, when somebody looks at my code, I hope they don't barf. I hope they look at my code and go, hey, they did a good job. Hey, this is a great organized database. It is quick, it's easy, it's well documented. Because I've had 4 or 5 months worth of work that somebody replaced in 2 weeks with much faster code. I was like, you jerk, you ruined my code. No, she couldn't have done what she did if I didn't organize the absolute dog mess that was in front of me. I condensed it, and then she built on top of mine, and it was microscopic by the time we were done. But my ego was involved in the data, and it was like, my job was to provide a solution. So I had to remove myself from the process. So the best way to have it is just don't be that guy who's like, oh, you can never tell me what to do. It's like, no, please tell me how to fix it. And I've been able to call people who are crazy successful, and it's like, hey, can I have 10 minutes of your time? I've got a couple of questions about this blog post. He's like, yeah, sure, let's chat. So I actually got to have an email conversation with Guido van Rossum asking him questions about Python. I should not have emailed him, but he did reply. And a lot of people will give you their time, but show them respect to their time and write their notes down. Years later, I can go back. People who are senior software architects at Slalom, I've had hours and hours and hours. I wrote down everything they said. I still go back to use it. So it's not the cool, fastest way, but the batteries on my notebooks never go out. And it's, so I've learned a lot from working with you guys. The Joel test, if you just Google the Joel test, you'll see that up on Stack Overflow on thing. But, and eventually the Stack Overflow did reverse my ban, but I was asking a lot of bad questions. I could have read the documents, RTM, but if you don't, just don't be an asshole. I think that's about the worst thing. You basically just suck up information and nothing useful ever comes back out. And so, yeah, that's my talk, and I've learned a lot from you guys, so, and gals, so thanks for your time.
Eric, you want to just jump right up there?
Thanks for not wrecking my laptop.
So while he's getting ready, I'll talk about learning programming with my father. So my father is a very unique programmer, one of the top 10 OEM developers in the country at the time. And he taught me BASIC and taught me C, and what he would do is when I asked a question, he'd open up the manual and point, okay, read this section of the manual. And if I had questions on it, he'd answer questions afterwards. But yeah, he was always pointing me to the manuals. He has a question for you.
Is your 24-step version of that checklist available anywhere?
No.
Close source.
Oh, thanks.
No, it's not, but I could make part of it available. It's a lot of what's on Joel and then expanded. So I took the Zen of Python and Joel's thing together. But yeah, that was more, I can't remember all of these things that I have to do. So
All right.
All right, good evening. So, I don't use notebooks anymore, sorry. I will use paper every time I meet a client or I'm in a meeting, but I immediately write it down. And my motto is actually, teach it, that's the best way to learn it.
Are you on the Google Meet still?
To my knowledge.
Then check, there should be a button to share your screen for that guy.
Where would it be?
This one here.
This one?
To the right.
Oh.
Not that one. That guy. Yep.
All right.
Great. Entire screen over here.
Hmm?
Let's see if that works. And then say share at the bottom. Double check.
Okay.
Sorry for the pause. Yeah. We're good. All right, we got it.
Okay.
Recording screen.
So as I was mentioning, one of the best way for me to learn is to teach, or to actually write article about it. So one of the passions I had is actually a language that nobody uses called Harbor, which is basically transposed to C, and actually allowed me to bind in C Python. So actually can code in Harbor and Python at the same time. But I created a website to help the Harbor community to learn by writing articles, one of the things I did. But since I also like doing other languages, including one of them is Python, sometimes I will start a project not because I really need it, but because I'm curious about it. And one of the things I was curious about it is how to integrate Python as a procedural language for in PostgreSQL. How can I run Python on the server? And I use Postgres quite a bit in my career, off and on, and went back into it a lot with version 12, then version 13. The article was written in 21 when I was using 13. Because it is not on a notebook, I was able to ask ChatGPT, please check if anything changed. So I give it the URL, and it says everything in this article is correct except the installation instruction. They are a little bit different, but again, I make reference to links. Now, this article was written on Windows because I love Windows, sorry. I use Linux too, I use Docker all the time, but I love backups, so I do daily backups. Little tease, sorry. But yes, the Macs work very well too. They work very, very nicely. For me as a power user, I need something more robust and more graphics and more tools. So that's why I went with Windows. So my article was created under Windows 10 Pro. I'm running Windows 11 right now. So I had to reinstall, I'm using Postgres 17 on my laptop now. So every version of Postgres that you use is bound to a particular version of Python. In this article I wrote, you can actually go down the list, and it's going to tell you where you can find the version of Python you need to run Python on your server. So that's one of the biggest tricks to do. The second trick is, for it to work properly, even though I have multiple versions of Python running on my machine, and I never wanted to have the path, the Python inside a path, for the purpose of Postgres, the Python that you will be using for your Postgres instance has to be in the path unless you would start Postgres not as a service, but as an app. Then of course you can wrap it around and set a path beforehand. So that's a little caveat that you have to deal with. Again, I've got instruction about this. Now, I don't know how many of you do use stored functions, stored procedures. Okay, so maybe a third of you guys. So the idea is most of us at the beginning, we just do our select statement or insert statement or delete and so on. One of the big advantages of, so there's a concept, something called stored function. It's kind of creating a new command, a new function basically, like an add, a delete, whatever you want. But most of the time you would create a function to do things into your database, to add records, to update records, to work across multiple of them. But Postgres has a wonderful advantage that you can give like super user right if you want to a function for it to do whatever it needs to do, but not to the users that are using it. So you can have a user at a lower level access. Don't give that user access to your table. Have the function have access to your table, and it becomes a gatekeeper. That's one huge advantage. The second advantage is imagine a function is kind of like your library of APIs. It's basically that's what it is. It is your API to access your database, which means you're decoupling your structure, and you can modify your schema without having to worry about all the other developers using your system, and suddenly the interface, the API interface here, is different. You can manage it. And then again, if you have large companies where you have multiple teams, they want to have access to your database, but you don't want to give access to them, so you can make a store function for that purpose. Now, the function can be called in any select statement. So even select, name of the function, open close parentheses, will run it. Or it can be, if you have a column of some kind, like min, max, my max, my min, my average, whatever you want to call it, you can wrap it around. So those functions can be used anywhere. The procedures don't expect a return, so you can do multiple steps, but you can return a result set, you can return rows. Functions, you return a value usually. Procedures, you can return a table, a result set, and you can apply it. Now, another big advantage of procedures or functions is you can run multiple commands, multiple insert, multiple delete, multiple commands, massage it, and that becomes kind of a wrapped, again, function in itself, and you don't have to return data back locally, process it, return it back, everything stays on the server. So again, it's more labor on your side to make it work, but it has big advantages at the end. Now, Postgres comes with 4 major languages that are supported officially by the Python community, by the Python Foundation. Now, they always call PL for procedural language, and PGSQL, which is their native language, which I use all the time, which is extremely fast, it's optimized. But it is not the strength of a high-level language like Python, or like most other languages. There's TCL, which nobody uses anymore. Perl, again, it's a kind of a dead language, unless the one is there, and Python. Now, there are also some other languages, like we had a speaker that came about Ruby not a long time ago here, how he was running Ruby in the back end. You can run C, I even believe, and C#. There's a whole series, but those are provided by external repos, by external groups of people who maintain them. Now the two main issues is that the language can be what they call trusted or untrusted. Now, what does that mean? A trusted language mean that they will not restrict what you do in your language because they never have to be worried about you accessing the hard drive or accessing the resource or accessing the operating system itself and basically being able to destroy the server. Python is not a trusted language because you can have access to anything. You can call C in Python. So you basically have root access, root power to everything. So I know in Amazon they don't support that. They don't let you do that. But for you as a developer, if you want to do something that you want your server to do something for you, like some backups, you want to one of the examples I'm going to show is how can I have my server send messages to me? There's something called UDP, which is a way to send packages out. Not like TCP/IP where you have to send a message and wait for a response. You can have your server, your PostgreSQL server, send messages out. If somebody listens to it, great. If they don't, who cares? So there's no performance loss. I'm going to show that. Since time is a constraint, I'm not going to show the instructions for to install. There's a document for that, that's why I made it. All the steps in Windows, but again, there's a document for that. I use pgadmin all the time, so if you go to pgadmin, there is a command you can run to show me my list of installed languages. And you have to create an create an extension to actually add the language Python to your server. Actually, you install the Python configuration package comes with, so you install Python to be available to that server, and then you run the extension in any databases you want Python to be usable. So you have to remember it's a two-step process, okay? So I did, of course, install it, and that's why it appears here, PL Python version 3 untrusted. And let's go back to the document here. And the way you create a function, this is, for example, a simple function. Get Python version. Tell me the version of Python I'm running on my server. When you add this function, you are telling it which language you're coding in. If you don't put this, it's by default the PostgreSQL, their default language. But if you add other extension, other languages, you can actually code in different languages in your backend. Now, another trick is also event and triggers. An event and a trigger in Postgres calls a function. So if you can nail down how you do your functions, if you have a trigger, add a record, delete a record, whatever happens, you can make that tied up to a function, and that function can run your Python code. That Python code can send a message, can make a backup, can transmit it. Basically, whatever you can think about can happen. So normally, you can, of course, run this as a SQL execute, or you can go simply into your, actually, I have a little copy. That's the best thing, copy. So I keep my carriage returns, and you can execute, and now it added that function to the database. So under functions, if I dig somewhere here, I will find actually an entry that says get Python version. So if I go here, for example, and if I do select get Python version, there it is. I'm running Python 3.12 revision 6. This actually sent a select statement. There was only the return was whatever I returned that function, and it ran Python. All right. These are this is another way of running. This is called a what I forgot the name, an undefined code block. So you can actually execute multiple commands in one time as a command without registering as a store procedure. Normally, you have to add a store procedure to run a piece of program. Here, I did not. So here, I'm actually not running Python. I didn't put the language. So I'm running the generic language of PostgreSQL, not as a store procedure, but as like an undeclared program. So this would do the same. Now here I can create another Python store function. Again, create or replace, that's very important. So one of the problems, by the way, with store functions and procedures is handling versioning. So by default, I always do create or replace. So when I deploy something, just update everything necessary. That's the easiest way to do. Now there are some APIs you can actually call and find out what you have and read them and do so on. I just do brute force. But this again says I would be running in the Python language, the Python interpreter. Again, I've got some more example here. I'm not going to run them for time purpose because I want to run actually something pretty cool, which is the send a message, what I just mentioned before. I want to be able to actually send a message from the server to wherever I'm listening. So again, I'll copy this. Now I already had it done here, so it will be a replace. Okay, it completed. So I now install that function. Now, for this to work, you need to receive it. You need to be able to get the message. Now again, this is sending out on a particular port, and then you have to listen to that one. So security might be an issue. You have to set this up so your packages will go out. I have, again, in the document, I have a program that you can actually listen, which is listen to my messages. This is the pure Python side. I'm running Python 3.8, I think, on my client side. Even I'm running 3.12 on my server side. It doesn't matter. It's just a message going through. I'm listening to my local host. This is the port I decided. And I'm going to simply do a run. And it's ready to run now. Actually, it isn't ready to run. What happened? I tested this earlier. You know what? I think I have also an exe. Let me run the exe. Maybe that's going to work. I wonder maybe the meeting app conflicted it. To enable access forbidden.
Yeah. Maybe it's already run.
Do you still have it running, like in another window?
I'm surprised. Okay, well let me.
Running another window would already have the socket open.
Yeah, that's the risk of live demos.
I know,
It's live demos.
but you know it's fine.
It's the toughest thing to do.
You can just start sending packets and see if anything receives them.
It's okay. We can try it. Okay, my little playgrounds here. Yes, the Macintosh is a wonderful tool because you can't do anything with it. Okay, what is it?
Windows laptop for your talk.
Okay, let me try one more time here. One more time, and if it's not, then you can just trust me. You can, or you can try. I give you the article. It's probably because, again, I'm not connected to my Wi-Fi, so maybe something is messed up. Normally, this would work. So the next step is executing the command, actually. Where's my article here? Here. So again, you simply could call select and say message hello. If that happened, you would have seen in the UDP the message hello. Now, here's a cool thing. This, even though this is a Python command, let's say that you make your own store procedure or function in the PGSQL, the regular SQL, or any other language. There's nothing that restricts you from calling a function, a stored function, written in another language in whatever language you do. So the gentleman who was using Rust, he could call the same send message out. So even though he's running a store procedure in Rust, it's going to call the function, and internally it's going to be sending out via Python. All right, as I said, this normally works. Gotcha. I had also little examples about the store procedures themselves, or the store functions here, is how do you actually call the insert command from within Python? The way it's being done is that when you run Python as a store function or procedure, in the backend, you get a few exposed variables. PLPY is the one. It is a variable that has a bunch of methods. It's an object. And there is one called execute, and you can put whatever string you want in it, and suddenly you can execute your insert command from your Python code. Because this is the way you kind of you connect the SQL world with the Python world. And no, this isn't the case of a store procedure, so I actually add it, create it, and then I call it. This is how you call it. So this is not a function, but a procedure. But again, you can do this in your functions as well, this PLPY execute. Again, I show here an example about how to run this into one of those it's called anonymous code block. I got it. You can run basically whatever you put between these markers as a string is your command, and you can execute it. You're importing from a Python module, datetime here. You can import anything you want. And you can execute multiple insert. Here's also the description about the PLPY object: execute, prepare, cursor, commit, and you can also ask for error logs with it. Almost one of the last thing is it also comes with two extra in scope variables. One called SD, one called GD. They're basically dictionaries, Python dictionaries. So here, for example, I have an example of I'm creating my own counting function, and the SD dictionary is a dictionary that will remain across all the calls of the same function. So because you lose normally context, there's no memory at all, but this is kind of a memory. So the Python running on the PostgreSQL server gives you that particular variable. Now please be careful if you're running a multi-server environment. I don't know what's going to happen, but at least on a single server environment, this will work. So in this case, if the counter property does not, or element is not in the Python dictionary called SD, I'm going to initialize it to 0. And then I'm going to increment by 1, and I'm going to return it. So calling this function will basically automatically return me an incremental number from any time I called. And then the GD, global dictionary, is across any Python functions or store procedure you create. That's a way to communicate things between your functions. Now, these are session specific, meaning once you disconnect, those are gone. So it's not global to everybody, it's specific to your session. But again, this can be extremely practical for testing, for development, or doing something kind of unusual. I've got reference material for you here. And I've got a little text I cannot read because it's being hidden by my screen here. Oh, here, hide. So even though the native PostgreSQL language is very powerful and quite fast, the one built into it because it's compiled for it, Python, even though it's much slower, it is quite fine for all your needs and to add features you never thought about. Any questions?
The SD and the GD, I just didn't know about those. That's really cool because I haven't done a lot with field Python. Those are specific to like this. That's not like a Python thing. That's just Postgres, right?
Yes, so basically Postgres puts in scope those two tokens that become available. It's kind of a little bit when you make a web page, you have document available all the time. Even though they've never declared document is there. So it's kind of the same thing, it's an in-scope token, which is really cool. It's a very simple solution to add this flexibility between the PLPY, the SD, and the GD. You're covered.
You would need to be careful with connection pooling.
To be careful with connection pooling, yeah, probably. Because again, everybody's in the same session.
Right.
So that's why I mentioned.
And you might get different sessions if you're doing transaction pooling. You might
not.
Now
you could maybe, you have a virtual session number that you keep track of, and maybe making a dictionary that you have your pseudo session in it, but that's going to become fairly big. Now again, I would not, it depends again on the environment you do. Again, you cannot run on Amazon because you need super user access to be able to install it. You don't have access right to it. But again, you ask me, hey, can we speak about something about Python and Postgres? Well, this is exactly Python and Postgres. Okay.
Thank you.
Yes.
Oh.
So I can use GD to share context between different Python functions. Is there a way to share context between functions written in different procedural languages?
Yes.
While you answer questions.
Sure. What you would do is kind of like that trick like I mentioned, what you could do is create a function in Python that returns the value you need. And you basically create wrapper functions to communicate between them. Because again, when you call a function in whatever language they are, you have isolation. It's kind of like APIs, basically. It doesn't matter what you implement them in, they're available for you as long as you return statement. I think that all the functions are always by value. I don't think they're ever by reference. And I think the return is always a string. So if you have to return more than one value, make a JSON string. Okay, any other question? Yes?
Mostly curiosity, right? But I can trust that we can send a packet out. Can we also listen to a packet in? And if so, what resources are keeping busy when listening?
I don't think you can link it in. I don't think so. Because again, you need to have a listening port, which Postgres itself doesn't have. Sorry. So the question was, can we have a packet into the PostgreSQL server? I don't think so. Maybe is it?
Yes, exactly.
And you need to stop presenting.
Where's the echo coming from? Did you hear that? We didn't have it all night.
It's all my fault. I'm loud, but not loud enough to be recorded.
Thank you so much. Unless any questions. Thank you.
Thank you.
How about that? Yeah, that was just I think it was just me. I think it was my microphone. Okay.
Okay, so I'd like to apologize. I gave Jeremy the wrong title. It's not durable computing, which is actually a much broader area. It's durable execution 101 with Postgres and Python. My oldest son was born in 2003, about a month after the Mythbusters premiered on Discovery Channel. I'm an engineer, my wife is a teacher, and we are the proud parents of two now 20-some-odd young 20-year-old boys. To tell you that Mythbusters was on heavy rotation in my house when they were younger would be an understatement. I'm a huge fan. I have a favorite image. This is painting with explosives. This was my computer wallpaper for many years. I have a favorite segment, Bull in a China Shop. Look at me. Look at me. I have been told I was the bull in the China shop my whole life.
The screen is recording this instead of that.
Convenient. How about if we just, I can just do the PC screen. I don't need notes or anything here. Okay, nope. Display settings. There we go. So I cannot tell you how. I didn't change this. Oh, this stopped for reasons I don't know. Okay, so I have been told my whole life about the bull in the China shop. So to see this get busted, I cannot tell you how gratifying that was. And I have a favorite quote. Let me get rid of this here real quick. Oh, God dang it. Okay. Remember, kids, the only difference between screwing around and science is writing it down. I love this quote because it really captures the essence of science. Anything can be science as long as you write down what you're doing as you go along in a dollar, notebook. Of course, what's also great about this is I'm a computer scientist. I work for a company that builds durable execution engines. So the same thing can apply for reliability, right? The only difference between screwing around and building a reliable system is writing it down in some kind of durable storage. So this is a bit of a simplification, but for the purposes of this talk, memory, which is volatile, we are going to consider unreliable. Durable storage, hard drives, SSDs, whatever, is non-volatile and is therefore reliable. Now, again, this is a simplification. There are systems that involve replicating memory across hardware nodes to make it reliable. And obviously, your durable storage is only as reliable as your hardware is, right? You save stuff to disk and that disk faults, your system's reliability has just gone in the toilet. But for the purposes of this conversation, I want to focus on these things, right? And this leads to an axiom. This leads to an axiom if you actually hit the right button. System reliability comes from durably storing critical system state so that it can survive a system crash. Okay, great, yeah, but this is Postgres user group. Of course, we already do this. That's why we use Postgres, right? Right? I mean, I assume that for anybody in here who's running a Postgres database, you can show me a diagram like this. This is the DVD rental sample database, and it has all kinds of cool business entities like films and rentals and customers and stores, etc. The specifics of it don't really matter. I just pulled this off of dbdiagrams.com. This is an even bigger one. I can only show a segment of it. This is the AdventureWorks demo application from Microsoft. As far as I know, this is one of the bigger, I'm not familiar with a bigger sample database. I'm sure obviously there are bigger production databases, but I don't necessarily have access to them. This is the sales segment, so you actually see a lot of the same business entities, customers, stores, products, sales, what have you. Right? And you guys probably have in your systems similar kinds of, entity ER diagrams or entity relation diagrams. Are these actually capturing all of the system's critical state? No. You know, in fact, when you look at those diagrams, I see a lot of nouns. But what I don't see is a lot of verbs. Now, I have to warn you, this is a Python talk, right? And I'm about to show you something that is decidedly not Python. But we're going to make fun of it, so I feel like it's okay. This is actually some sample Go code from an actual demo that Google publishes. This repo had its most recent update last week. So anyways, we'll see. I'm flabbergasted by that. Now, I assume, I don't know how many Go developers are out here, but even if you can't write Go, even if you don't understand why you need colon equals, you don't understand why they don't know how to spell null, you don't understand what the stars or the ampersands mean. Look, the specific thing, you can probably read this, right? We're creating an order ID, we're grabbing information from the cart, we're calculating an order total, we're charging the credit card, we're shipping the order, blah, 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 right? I made a very small couple of refactorings to get this to fit on the slide, but this is the actual live code that Google is telling customers how to build microservices. Now, I know we're not Go developers here. I do want to make one quick point here. Go does not have exceptions. This is how you do error handling in Go, right? So if you would imagine you're calling a function, it throws an exception, you don't catch it. This is the same thing in Go. In Go, if you have a function that can return an error, you return a tuple where the error code or the error object is the last value, and you check it against to see if it's null or nil, because whatever. It is really hard to write Go and then NU backspace I, NU backspace I. Anyway, so all we're really doing here is we're checking the error, and of course the vast majority of the time we're just passing that error up the stack, right, to whoever called us. So here we're looking to see, did this function succeed, and if not, just return to the calling function, okay? So that's all the Go you need to understand in order to understand this slide. So there is an absolutely egregious bug on this slide. It is an absolutely ridiculous, egregious bug, and it astounds me that in the 2 years that this demo has been out, they've never fixed it. Anybody see it? Nope. The dunder is, the way the dunder works in Go is Go will not let you ignore a return type. So the dunder means, yeah, I know this returns something, but I'm not going to look at it. That's actually not the error. Since we're running short on time, I'm just going to show you. If we ship the order, if we call ship order and it fails, we bail, which is really a problem because we just charged the user's credit card. I'm sure they won't mind. We charged your credit card and didn't ship you anything. That's astounding to me. As I said, this demo has been out for 2 years and they've never fixed it. Now, we're not Go developers here. Well, I've written some Go, but I'm not a huge fan if you can't tell. Let's stipulate for the sake of argument that there is some way you could structure this code correctly. Right? It's not this, there is no revert charge function, I'm not checking the error, blah, 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 blah. But for the sake of argument, let's pretend that this is valid code. What's the other problem with this code? Much more on topic for the subject of the presentation, I might point out. So let's imagine that instead of calling into ship order and it returning an error, the system crashes at this point. Now, I know nobody in here writes buggy code. Ever, 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 right? Nobody over here has ever written a recall class bug that was discovered as you were walking into a hockey game on the other side of the country. That's kind of specific, Harry. Yeah, well, you know. But this code is running in a container or in a virtual machine, which is running on an operating system, which is running on hardware. And even if you don't have any bugs in your code, there's all kinds of things that can go wrong underneath you in the stack. So this is the reason why we use a database, right? Because if system crashes, we have stored stuff, important stuff, critical system information, we've stored it in the database. But we haven't stored any of this information in the database. There's probably some kind of important stuff in here. Like, well, okay, well, we're generating an order ID. There's it's actually 0% chance we could ever get this order ID back. Now, maybe it's not that big a deal. We can create a new one, right? If we go to re-execute this code, no problem. We generate a new order ID. We're going to pull data out of the shipping cart, out of the shopping cart and calculate a total, assuming we still have access to the shopping cart and the product catalog. These are read-only operations. This is probably not a big deal. But again, same problem. We've charged the user's credit card. We haven't recorded that we charged the user's credit card. We didn't write down how much we charged the user's credit card. We didn't write down that convenient little transaction ID that the credit card service returned to us, or the credit card function returned to us. So how are we possibly going to recover this application after the crash when we have not, in fact, durably stored any of this information? So the subsequent axiom after the first one is, yeah, we need to store critical state, and process execution state is critical state. If you do not store it durably, you are not reliable. Well, okay, so there are some exceptions. Not all process execution state is critical state, right? And part of what learning about building durable execution systems is to be able to identify that. And this is a short talk, so I'm not getting into a lot of detail, but there's two things that you usually do not need to worry about when it comes to persisting process execution state. First off, if it's read-only, you probably don't care, right? You just re-execute the query, right? The second thing is process usually implies more than one step. If you have a single step, you put it in a transaction, and you're done. You don't usually care about making that, right? Either it happens or it doesn't happen. So in those kind of cases, it's multi-step but read-only, or it's a single step, you probably don't care about making sure that that process execution state is reliable. But any other scenario, any kind of multi-step execution, you have to be able to save the state of your process in order to be able to recover it reliably after a crash. So, durable execution environments, I'm going to use DBoS terminology because that's my employer. But you can get the idea, right? Maybe these are called processes and checkpoints or whatever, or tasks or whatever, it doesn't matter. DBoS introduces two constructs, workflows and steps. Now in code, as we'll see in a minute, these both get mapped to functions, but they are conceptually different. A workflow is a series of steps that is guaranteed to run to completion. If you crash in the middle, when we reboot the system and it comes back up, we automatically find all of the workflows that were incomplete and start them up again, automatically. We automatically continue from the last step that we executed. We do not re-execute steps that we've already executed once. Workflows have to be deterministic. If you need undeterministic stuff, you put it in steps. And then this is very specifically a DBoS thing. I'm not sure that this applies to all, but I imagine it applies to all. Input parameters and return values must be serializable. I'm going to restart if I'm going to pass in a bunch of code, a bunch of data in parameters to a function, and I've persisted that on disk, I'm going to have to be able to rehydrate that if I have to restart this workflow over from scratch. For steps get automatically checkpointed after execution. We save the information to durable storage. We verify before execution. Hey, have we already executed this? If not, then run it. If we have, just go get that result and return it. We don't need to run the code again. Because of that, it can be non-deterministic. I had the benefit of working for Pat Helland, with Pat Helland, and he's got a paper over there in the library, and he talks about the fact that you can make anything idempotent if you give it an ID. Withdraw $1 million from your bank account, that's not idempotent. You can't execute that multiple times. But create an operation with a specific ID and withdraw that money if that ID hasn't been done, that makes things idempotent. So we automatically assign every workflow and every step a unique identifier in the system. And input parameters don't have to be serializable, but return values do. We only store return values, at least in DBoS. Again, different engines may do things slightly differently. So let's see what this looks like in code. And so here's a workflow that's made up of a couple of steps, or a set of steps. And the first thing we're going to do when you call into the function is we're going to save into durable storage the fact that you started this function, right? Because if we're going to be able to recover it later, we have to know this workflow was in process and it's not complete. Then we're going to execute the steps, and after we execute each step, we're going to checkpoint. We're going to save the information of that step, which is to say the return value. We're going to save that to the same durable storage. And now, like we saw before, let's imagine there was a crash. We reboot. So now we got to start over from scratch. When we go to execute this workflow again, we go and we look in the database and we say, we've already run this step. We don't have to run it again. Here's the result. And then we just continue on from there, finish the workflow, and when we're done, we save that state to the database too. Because it's possible that, hey, the system crashes again. We don't want to re-execute this workflow. It's probably not a big deal because we've taken all the deterministic stuff, all the important things like updating the database or charging the credit card or all those kinds of things. Those live in steps, so we don't re-execute them even if we were to rerun this function 1,000 times. But obviously, there's no point in rerunning this function because you've already finished it. So this is, again, live code. This not buggy. This is Hello World using DBoss. So in here, you'll notice that right off the bat, I've got it on 2 slides or 2 columns just so we can read it all, in one slide. We're going to configure the DBoss infrastructure. Now you'll notice here, we're specifying a Postgres URL. There are a variety of different durable execution platforms out there. DBoss is the only one that stores all of its information in Postgres. Though the Python version now does also support SQLite for dev purposes, but we very specifically do not recommend running that in production. So we have to have a database to store this information. This is, you can query it, and we have tools to make it easier. Plus, of course, you can query it yourself, but this is decidedly not designed for you to mess with. And then we have a workflow. Now this is Hello World. So, but you'll notice we've decorated. I'm working on the Go version. The Java version of this right now. We just released the Go version, and I'm currently working on the Java version. So the terminology differs from language to language. We've decorated the workflow function with the dboss.workflow decorator. So what does this do? If you know how decorators work in Python, it adds a bunch of code at the beginning to save hey, we're starting a workflow. If you give us an ID, we'll use it. Otherwise, we'll create a GUID, and then we call your function, and then at the end, we record the result. On the right-hand side of the slide, you'll see that we have a series of steps. Now, these steps are all pretty much identical. Again, this is Hello World. This isn't a very interesting one. The business logic of each of these steps is to take a nap for 5 seconds. But in our demo, which if we have time for, we'll get all the way through the slides, and if we still have time and anybody wants to hang around, I can show a demo of it. All of our demos have a crash button. Please crash me in the midst. So that way when you start it back up, you can see everything pick right up where it leads off. So if we crash while we're in the middle of step 2, when we come back up, we'll see, hey, this workflow was running, step 1 completed, step 2 did not, so we're going to have to run that again. Now again, this is a pretty simple scenario. So let's take a look. There's also a demo app we have called the Widget Store. So this is a little bit this is obviously much more realistic code. This is more along the lines of what we saw in the crappy Go code that we saw earlier. Every function, so we noticed that at the top here, that this is a DBoss workflow. So it will automatically checkpoint at the beginning of the workflow, and it will automatically update the workflow state at the end. By the way, it'll also, if you throw, it will also record that. So it invokes your code inside of a try-catch block. All of these functions in green are steps. They're actually a special kind of step. Our Python version includes a support for a specific type of step called a transaction, which is to say, for every typical application for DBoss, we have, in fact, especially when you deploy to DBoss Cloud, you get 2 Postgres databases. One for us to use for the system database information, and one for you to use for whatever your normal kind of database application. And this being a storefront, you can imagine, we track, again, similar to the ER diagrams we saw at the beginning. So when we create an order, we're creating a record in the database. When we reserve inventory, we're modifying the products table, et cetera, et cetera. One of the things that's really nice about the transactions is that we'll start the transaction for you, we'll run your code, and then we will persist the result of your function call and then commit the transaction. So it's very, very safe. However, we've also discovered that a lot of customers are only interested in the durable execution part. So they don't even care about having a separate database. So we're moving to a different model. The TypeScript version uses this today, where we have a separate construct called a data source. TypeScript in particular has like 8,747 different object relational mappers and query builders, and we don't want to support all of them in the core. So we've built this extensibility mechanism, which we haven't yet ported to Python. But we are planning on doing something for that space. The Go and Java versions currently, the Go and just released Java is still in development. We're only recording the step information. So if your step is talking to a database, you know, we're not running the transaction for you, but you can still do that. You'll also notice that there's other functions in here that are headed with DBoss. DBoss has a rich messaging and eventing infrastructure. So you can send messages to workflows, workflows can receive messages, workflows can raise events, and code outside of the workflow can consume it. So the specific example that's happening here is the demo is working in that this code creates the order, it reserves the inventory, and then it sends the user off to a payment system, like something like Stripe or PayPal. I mean, this is a demo, so we're not actually doing that, but it's going to raise an event to say, hey, this order is getting executed, so go redirect the user to the payment system. And then it's going to wait for a message to come back. So most of these systems work off of a webhook type of system. So when that webhook calls, we get the package back from the payment system, and we send a message to the workflow that's associated with it. That receive will last as long as your application runs. You can put a timeout on it if you want. Hey, I want to hear back from this guy in an hour. I want to hear back from this guy in a week. I want to hear back from this guy in 3 years. One of the things that's kind of cool about DBoss is that infrastructure for sleeps and timeouts are durable. So if you say, I want to wait an hour for this, and the system crashes half an hour in and reboots, when it comes back up and says, okay, well, I did all these first steps, I'm on the receive step, I haven't received it yet, I'm supposed to wait an hour, but I've already waited 30 minutes, so I'm only going to wait another 30 minutes. So it doesn't automatically restart the waiting process. The other thing I want to point out on this slide is the function called start workflow. Because we're adding decorators, right? So we add code at the beginning and end of the function for both workflows and steps to do the bookkeeping that we need. When you call the function, you get back a result as soon as it's ready, just like you would with a normal Python function. We do have async support as well, but we're not showing that on this slide. In this case, we're starting a separate process to do dispatching the order, but we don't really want to wait for the user we're not going to wait for that process to end. That could, who knows how long it's going to take to actually ship the product to the customer. We're not waiting. We're not going to wait on this process for that to complete. So here we can actually start another workflow from this workflow, and that is all connected inside of the database. So we can actually query and see what the relationship is for all of that kind of connection. And all of this stuff is just core infrastructure that DBoss provides. So there's a variety of cool support features we have in DBoss. We've talked about a couple of these. It has got a Postgres systems database. This is an embedded system, not embedded like small CPUs, but it is included inside of your application. It's a library. The vast majority of platforms and products in this space are standalone products that are used as their external systems, and they're used to coordinate other services. One of our big competitors is Temporal, and one of their big advertising, they advertise this. You should use Temporal Cloud, because if you run Temporal locally, you need 4 senior engineers to the tune of $2 million a year. Can we use that in our advertising? I don't know. Here, it's just part of your application. It's just storing data to Postgres. Like we were hearing about with the DocumentDB stuff. If you've already got Postgres, you already know how to run this stuff. So it's just a library and running Postgres. If you're building a Postgres application, you've already got all those expertise. We talked about transaction steps, a specific kind of step that knows how to read and write to the database in a transactional way. We have a bunch of infrastructure for queuing, built into DBoss to support concurrency. We have scheduled workflows, which is a durable cron kind of infrastructure. We talked about workflow communication, messaging, events. We also have streaming. We actually have a variety of customers that do durable LLM stuff. We just got integrated, the Pydantic people just accepted our PR to integrate DBoss into their product. And so a streaming is like a step that isn't complete yet. And so there's some tricky things you have to do since the step could be not all the way done and crash. Workflow management, we can cancel workflows, resume them, and we can fork them. If we go back to that Go code we saw at the beginning, there's this egregious bug. Durable computing or durable execution doesn't solve egregious bugs, but you can fix your code and then say, hey, I want to go back to the point where I crashed, or the point where I saved the, where I charged the user's credit card. I want to create a whole new instance running on my new code that fixes the bug. We have a cloud console that allows you to manage this stuff. So we have an API that you can use for doing this kind of workflow management, and there's a UI. You can run this stuff in our cloud, or if you want to run it on premises, we have a tool called Conductor, which allows you to use our cloud infrastructure to manage workflows while running in your own data center. And we have a replay debugger for VS Code, so you can actually take any workflow that you've executed and walk through it, the code, the workflow code, inside of Visual Studio Code. So I don't know, we can do demos here in a minute, but let me just finish up the slides here. To go back to the quote from beginning, remember engineers, you're not kids, the only difference between screwing around and a reliable system is persisting all the critical state in durable storage. All meaning your business entities and your process execution state. My name is Harry Pierson. My email is here, harry.pierson@dboss.dev, and I'm DevHawk on most social networks. I'm trying to move over to use Blue Sky primarily due to a severe lack of Nazis, and so that's my Blue Sky handle. So, I have time for some demos? Okay, you guys can leave if you want, but I'm going to show some demos. So, oh look, we've lost the screen again. So let me restart. That's convenient. I like how that keeps happening.
While he's doing that, I'll just sort of throw one more thing out. Like the theme of the night was Python and Postgres. So if questions, as you wrap up the demos, questions for any presenters, if you have anything, it's all on the table. And also like just topics. Start thinking about if you have other topics about Python and Postgres that you want. We have a lot of people here who can just talk about anything. So
yep. Demos. Okay, so this is the starter app. We saw this was the Hello World app. So I'm just going to run the application, and oh, okay, what? P screen only? Duplicate. No, it's my setting. Okay, there we go. Okay. Nah, this was just a screen problem. So I'm gonna launch this code. I'm gonna click the right button here. So I've stopped recording again here. This has been really problematic today, the presenting. Anyway, so here's this is the Hello World application we saw before, right? So we have the workflow with the 3 steps. This is slightly modified. The set event that we saw on the code earlier is so that when we can actually see this visualized in the UI. If I click on Launch Durable Workflow, you'll notice we've given it an ID, and it's going to execute these, and as the code actually executes, it'll update the HTML. If we come over and we look at the code running, we can see here that it's actually running our logger. We can see it's actually running here. So completed step 1, completed step 2, completed step 3, etc. Now I'm going to run this again. One second. Let me just get through this part of the demo. So I'm just going to get to the second step, and I'm going to crash the application. So we'll notice here we've gotten to disconnected. It's trying to reconnect. If we come over here, we can see, hey, the code really is gone. If we look at our code, we're just using a fast API here. You'll notice we have a crash endpoint that just calls OS exit. We are really crashing the system. If I was doing this demo in DBoss Cloud, it would automatically pick up and restart, but because I'm doing it locally, I've got to start the application again by hand. And so it automatically picks up where it left off. Now, because we're using a normal sleep instead of a durable sleep in this context, that 5 seconds did start over again. We could have used dboss.sleep instead of time.sleep, and that sleep would have been durable. So it would have, however long it had slept before it crashed. In fact, because it took me longer than 5 seconds to talk about it and restart it, it would have just immediately completed and gone on to the next step in that context. So I'm going to show you real quick in the database. So this is the database for the starter application. We can see here we have a table that has all of the statuses. So we can see here we've run I ran it once as a demo before I stood up here to make sure that it was going to work. We can see here's the information about the workflow, its status, what was the name of the function. There's some security information if you're doing it. We're not obviously doing any of that here. We're pickling this information. I don't really know much about the serialization format, but this is obviously some kind of bin hex format, with the 2 equal signs. It's kind of a giveaway. Where when we created it, when we updated it, you'll notice we have an application version, right? So we can actually strongly keep track of which version of the code was running for each individual workflow. So if you deploy new code, we won't try to actually run the code from an old version we won't run a workflow from the old version of the code with the new workflow. But then you can fork it and say, yes, I do actually want to do that. So all of this information is here, and we just use that information. In fact, you'll see here recovery attempts 2. That's the one that we crashed. So when we started running the code, it immediately started running. That was the first recovery attempt. We started building this code, and there's a variety of things that if we could, we'd go back and name things, but of course, we can't because it would break all of our code. So it's execution attempts, not recovery attempts. And so you can see here the second one, we ran that when we crashed it, and then when we started back up again automatically, it just started executing automatically, and it picked up and it kept track. By default, it will only try to run things 50 times, and then it'll stop. You'll notice there's queuing stuff. We can also put timeouts and stuff like that and what have you. And so there's also a operations table. So if we look here, we can see that for every one of these workflows, each of these has 6 steps. We're calling step 1, step 2, and step 3. Those are the functions we're calling, and then there's the set event. So this is a built-in function, so it has the dboss prefix. So that's what allows us to say, hey, we've already called step 1. Hey, we've already called set event. We've already called step 2, et cetera, et cetera. So that way, when we go through and re-execute, we know which ones we've already done. As I said, we've given every workflow a unique identifier, and every call just a monotonically increasing function number. So I think since we're running so late, I'm not going to do the other demo. If you want, you can obviously ping me. I'm on LinkedIn, and you can very easily, we have it running up on the cloud, our cloud. We can very easily give you access to it. We do have a free tier, so you can sign up for it and start playing with this. It's all open source. So anyway, with that, again, my name and email and contact information. Question?
I have 2 quick questions. Can you pull up the slide that had the fixed version of the...
The Go?
Yeah. The one with the DBOS.
Oh, the Go code or the DBOS?
Yeah, that.
This one.
So the first quick question is this one big step, or do the DBOS things induce checkpoints?
This is a workflow. You can see at the very top it says workflow. Each of these green boxes and each of the functions that start with dboss are a step. So after every single one of these green boxes and these dboss ones, we will checkpoint a step.
Okay, so my other question, when I'm implementing a multi-step workflow like this, I have to consider at any point between DBOS calls what would happen if that part was rerun from the beginning,
right,
before or after I got to the end.
Yep, you would have to do that, which is why you would notice, for example, in here, the only code that isn't a step is like a logger call. So like if you go through this, if you had a logger function like at the top that says, hey, I'm going to log out that we're starting this checkout workflow, every time you execute it, you'll get that log. But that's a log, that's probably not a big deal. But like create order, reserve inventory, right? So if you crash, like so for example, let's imagine we crashed, waiting for a customer to come back, and when we come back up, we start again. We've already reserved the inventory, that's gonna return true or false. So we'll just go into the database and say, what was the return value? Oh, it was true. So then we'll say, okay, well we skipped the if statement because we already have a value. So this is gonna be deterministic because of the fact that each of the individual steps, which are non-deterministic, we will return that value as it was executed the first time. So, for example, in this case, we've already reserved inventory for this order. We don't have to re-reserve it. And then if the payment fails, we'll undo that reservation, right? So we'll just put that value. I mean, we're just incrementing and decrementing a column in a database for this demo. But okay.
I was just wondering, do you need the concept of like nested workflow or nested steps? How do
Do you need it?
Yeah.
Well, we have it. You do, because again, we do have customers who you don't have to use it, right? So you don't you could imagine an entire scenario wherein instead of having starting a workflow from the checkout workflow, you write some information to the database that says this order is ready for processing, and then you'll have some other background task that comes along and picks it up. That's actually one of the scenarios. In fact, I think in this sample, we're continuously updating the order process. It's fake, right, because it's a demo, but we're using the durable cron. So you could imagine a scenario where you're like, oh, I want to find all the orders that are waiting to get picked up, and I'll just start a cron job every 10 minutes, and I'll just do that, and I'm going to do that durably. Okay, I think that's pretty much it.
One more quick question.
Oh, hit me.
The durability, like the system crash case makes a lot of sense, and I've heard you talk once or twice before too. But there's a question that popped in my mind that wasn't totally clear to me. Is like, would this also apply to like one of the workflow steps crashing, but not like outside of, or like a function? I don't know. Like if a function hits a null pointer exception and it just blows up, like is that a use case that you're concerned with here? Or
Not so much for, okay, so the question was, what about a crash inside of a step?
Yeah.
So if it's something like, if you have a step that's, got a bug in it and is trying to divide by 0,
right.
Every time you execute it with the same input, it's probably going to have that same problem. So for that kind of scenario, no. But you could imagine a scenario where like, hey, what if this payment system that we're working with was not, like if you go off and send it to, you want to send something to some system, some other system, that system may be down.
I mean, you talked about how you could, like, early in the presentation, you gave the example of, like, something crashes partway through a workflow, I push a new version of the code out, and it's able to resume. So, like...
Yep. So there's all kinds of those types of scenarios. Steps in DBoss, at least, have, like, retry semantics that you can set. So, for example, if you have a step that's going to go and retrieve some information from some other service, then you can automatically have it retry. You do have to be careful in a lot of those situations. If you've ever looked at how things like Stripe work under the hood, they use unique identifiers in order to make things idempotent for the same exact reason why we are storing, workflow IDs and function and step IDs, the same exact reason, because again, if I say I want you to process this payment, every time you send it, it's going to process it again. But if you say, I want to process this payment, and it has this unique identifier, only do it once, then you're okay. So it's the same problem. In fact, it's hilarious. We joke about this internally. Don't hit the back button in the browser, right? Don't hit that. This is the problem. This will solve that problem, because you would have some unique identifier, and if you submitted it again, it would say, oh, I'm already running this workflow, or this workflow is already complete. As you can imagine, we are designed to be able to work. We didn't talk about it very much, but you can run lots and lots of different, application server nodes, and you can have workflows that are running on the different nodes. And an individual workflow can only run on one node, so we actually have code to detect if I'm running code, and I said, hey, I'm going to run this step, check to see whether it's got a value. It doesn't. Okay, run the code, and then go to write the result, and it can't because there's now a record there. It means, well, there must be some other code executing that's trying to run the same exact code, and I'm the loser, so I'm going to stop and wait for that one to finish. So there's a bunch of really cool logic in the system that allows, for detection of the same workflow executing on multiple pieces of hardware, and so that the one that's losing stops executing and stops trying to run.
Okay.
And of course, that's part of the reason for wanting things like the transactional steps is that, oh, I tried to make this change to the database. They already made this change to the database. I'm going to roll back my execution of that. Yeah. So having the built-in support for transactional semantics and steps is really powerful. You look confused.
Well, I'm just thinking, trying to figure out, like, my original question, like, was, like, just sort of what are use cases? You know, like the system crash was obvious, and you were kind of saying, if I heard you right, like you weren't really focused on like bugs in code necessarily as like a primary use case for it. Something I can easily imagine though, for example, with work, you know, you have workflows like this, stuff's calling out, right?
Sure.
So you have steps that hit an API server.
The very first customer that we had was a customer that was integrating Shopify and SAP.
Right.
Right. So it's all remote calls.
But I can
to external
easily
systems.
see just a situation where you have a bunch of workflows that are just like stuck in an intermediate state.
Yeah.
And it's not that a system is crashing, it's like there's a problem with the API server.
Yep.
Some downstream service is offline.
Yep.
Right? And so that's not so much about crashes,
Sure.
but like it is about like I have all these processes kind of stuck and now I need to think about things like maybe back off on your API calls. Like I don't know if that's in
well,
there.
and all of our retries have the back off.
Yeah.
And for that kind of a scenario, you can imagine, as I mentioned, we will by default retry like up to 50 times. So there's some downstream server that's offline. You go through, you try 50 times with back off, and then you're like, I can't complete. Right? So you like if you.
But it's still in the system, right?
Yeah, it's still in the system.
So,
it's
like,
still in the
if
database.
we
So you
fix
can
the
imagine
thing, and then
once the
there's a way
system
to
comes
go
back up, you can say, hey, I would like to resume this workflow and start it again.
Yeah.
Or if you're like, hey, this workflow, this service I'm calling out to is now permanently down, or I had to change the way I call it or something. So I'm now going to deploy a new version of the code, and I'm going to fork this workflow to the new version of the code. But I only want to pick up here, right? So I want to pick up, like I already created the order number, but I haven't processed the payment yet. So I'm gonna start here, kind of thing.
Yeah.
And we have tools. We have code like a client class that you can use to build. Like if you wanted to build a administrative console, we have our own administrative console that you can use that will automatically show you all of your workflows. I might actually be able to show that real quick.
Well, I think the short answer is yes. Like it's more than just the crashing. To my question, like it's
Yeah.
more than just the crashing use case. There's a lot more to it. There's also downstream service issues, maybe some kind of a bug, you know, or it might not be a bug, but like it might be
Yeah.
like you need to do a deployment to resolve the situation and then resume the workflows, kind of a thing.
Right. So this is the same application, but as you'll notice in the URL, this is running in the DBOS cloud rather than running locally, right? So I can actually then say, hey, I would like to see.
We still see the slide.
Oh, damn it. It's the other window. I can see it though on the screen share. Great.
Great.
Let's
Isn't
get
that
it
awesome?
started.
You can just tell us when it looks like okay.
Yeah, we should probably open it up for other questions too in a minute.
Let me just show this one thing real quick. Okay, so this was the sample application. It's running in the cloud. You can see here this is running in cloud.dbos.dev, and I can see here and I can go to this workflow and I can see the workflows that have been running. All right, so here I've only created one because I just created this. I can see the workflow steps. So we have this nice visualizer here. I am not the visualizing guy. This is obviously pretty simple, this one. You'll notice here we have a fork button. So I can say at this point, hey, I'd like to fork this into a new execution. So now it's going to spin up a new workflow at that point. So now in this context, of course, I didn't need I didn't deploy new code, but I've picked up this second workflow and it started at that same spot. So like all of this stuff is built right in. Again, we have cancel and resume right here. They're grayed out because this workflow is complete. There's other stuff. I don't have a separate version installed here, but so there's all kinds of tools that we have to be able to do this. And as I mentioned, this is the DBOS cloud, but if you use DBOS Conductor, which allows you get this UI interface on our cloud console, but with code running in your own data center. So you can self-host our library and use it with this infrastructure for managing your workflows.
All right.
Okay. So other questions then?
Questions? Oh, for any speakers.
Any speaker, yeah.
Oh no, that's actually still for you. I saw that you were Pythonic by using the decorators.
Yep.
So can you explain your experience in switching from the other kind of languages that you supported to that, or the pros and cons of using decorators, because you could have stayed not using decorators?
So TypeScript's actually really the interesting scenario for this one, because TypeScript decorators, so JavaScript doesn't have decorators, TypeScript does. And there's two different kinds of TypeScript. There's we jumped ahead of the spec, and then that version of the spec got cut, and they had a whole new version. So there's two, like, experimental decorators and real decorators, and it's a real pain. We have a variety of customers who want to be able to use it from JavaScript, which don't have decorators. So in our TypeScript code, we actually have the ability to register, like, imperatively. You can pass a workflow and say, I would like to run this I'd like to make this a workflow, and you hand it the function, and it will hand you back a version that's essentially got the decorator code. And then for steps, we, especially in Go, and because then of course, decorator approaches don't work anywhere near as well in statically typed languages like Go and Java. So we also have a mechanism where we can say, here's a Lambda, and run this as a step. In fact, I might even have, I don't know if I have an example of that handy, but the thing that's nice about that is you can just take any function, right? So you just have a Lambda that calls any function, as long as its return type is serializable, you can do anything you want.
But it seems Python was one of your last language to implement?
No, it was our second language to implement. So TypeScript was our first, and then Python, and in fact, I mentioned earlier about, like, embedded versus external runtimes. We were originally an external one, or a framework, and one of the things we've discovered from talking to customers is, hey, we really like this stuff, but we don't want to rebuild our application from scratch to take advantage of it. We'd like to be able to integrate it into our existing application without having to rewrite it from the ground up. And so when we built the Python version, we built it as a library, and then we've had to go back and incur a lot of technical debt making the TypeScript version behave like the Python one. And then the Go version, as I said, it shipped this week, and Java first preview will ship probably by the end of the month. It's most of the way there. 20 years of .NET development, and I'm writing Java code. It's hilarious. Other questions?
This might be theoretical, but eventually you do need to make a network call to the payment processor to actually charge the card. And either that API allows you to specify a session ID that you've opened before so it can become idempotent.
Yep.
Or it doesn't. And if it does, you're good. And DBOS maybe helps. But if it doesn't, then even with DBOS, there's still this tiny race condition where you might end up charging the card twice, right?
Yep, and it's the same. It's a similar one that we're running into. If I showed you the Java version of the widget store, right? So if we actually, let me show you real quick. If we go to the widget store app, we showed this code on the slide, right? Checkout workflow. If I go to create order, we'll see that this isn't marked as a step; it's marked as a transaction. So this is a special kind of step. So what we'll do is we will run this code. We'll start a transaction. We'll run your code, and then we'll take the return value. We'll save it, and then we'll commit the transaction. For Python or for Go and Java, we have not implemented the equivalent of this yet. So we have the Java version of this application. We call this, but we don't manage we don't manage the transaction. So it is conceivably possible that you say, hey, run this step. Haven't run it before. Execute the transaction. Save the transaction commits. And then write the result to the system database. But somewhere between the transaction in the app database committing and writing it to the system database, you crash. So there is a small gap there. Now, we will be fixing that before probably not for preview, but we will support the concept of data sources in Go and in Java. And one of the things that's actually really nice about that is because we've disassociated it from the core platform, you could theoretically use any transactional data store you wanted. So if you wanted to write, I want to use DBOS and it uses Postgres for its system database, but I'm running MySQL or Oracle or whatever, you could theoretically do that. We're not going to provide adapters for Oracle or SQL Server, but we will do ones for Postgres. I don't know how many people know this, but one of our founders is Michael Stonebreaker, the original creator of Postgres. So we are a very, very heavy Postgres shop. He was not consulted in the decision to add SQLite, but it does make developer easier. It is funny. I went to run this demo this afternoon, and it has been a while. the last time I worked on the Python stuff was before they added the SQL Server stuff, or the SQLite stuff. So I go in to say, hey, I want to look at the database, and it's not there. What the fuck? Oh yeah, SQLite. So I had to go in and actually, you'll notice that there's a change here. The change here is that you have to set the URL explicitly to be Postgres in order to get a Postgres database. Otherwise, it'll use SQLite by default. All right. Python's the only one that does that at this point, though.
I have a question that has nothing to do with DBoss. Did anybody else have DBoss questions? I want to know, has anybody here kicked the tires on Postgres 18 yet? Because that just dropped last week.
September 22.
I'm going to start shutting down.
Yeah.
Okay.
Yeah.
I have not.
Okay. I'm excited. It looks really good. Nobody though? Nobody yet? Oh, you guys got to go try this out.